Hello, ladies and gentlemen, and welcome back. Root Beer here, looking at question number 7 on our 2018 Euclid Math Contest. So, we got a light bulb question for part A. 8 people, including triplets Barry, Carrie, and Mary, are going for a trip in 4 canoes. Each canoe sits 2 people. The 8 people are to be randomly assigned to the 4 canoes in pairs. What is the probability that no 2 of our triplets will be in the same canoe? Okay. So we want no 2 of the triplets to be in the same canoe. Now, there's probably 2 ways we could go about doing this question. It's going to be a counting question, and we could either try and count directly the number of ways that Barry, Carrie, and Mary can't be in the same canoe, or we might try and count the number of ways that 2 of them will be in the same canoe and subtract that from the total number of ways to split the people up. I don't know which one's better just on the surface of it, so I'll probably try for the direct route first. Okay? And then if that becomes difficult, I'll try and flip the question around and count the things that I'm not interested in and subtract that from the total. Okay? But it is a probability question, so we are going to have to figure out 2 things. We're going to have to figure out number of cases we're interested in. So the number of outcomes we want, that is no 2 twins in the same canoe, divided by the number of possible outcomes. Okay. That's always my go-to setup for probability. You can do probability other ways by figuring out weights and things like that, but this is usually, I find, the simplest way to do things. Okay. So let's see what we can reason out here. I'll draw canoes. And each canoe gets 2 people, alright? So, what can we do here? So, how many ways are there to... Maybe... Alright, so Barry's got to be in a canoe. Right? That's guaranteed. So actually, maybe I need a bit more space. I drew my canoes kind of small. And we don't actually need the canoe shape. Just 1 canoe, 2 canoe, 3 canoe, 4. So Barry has to be in a canoe. Right? But we don't want Carrie in... So we need to have the canoes be split up like this. Barry, Carrie, and Mary. And so what choices do we have? We got 5 choices for the people in Barry's canoe. That leaves 4 choices of people in Carrie's canoe. 3 choices of people in Mary's canoe. And then... the remaining 2 people have to go in the last canoe, so it doesn't really matter, because canoes don't have any order, right? Yeah, just each canoe sits 2 people. It's not about who's in front or who's in back or anything like that. So there's no choice here. It's just 4 times 3. So it's 5 times 4 times 3. That's 60 ways to put the people in the canoes with Barry, Carrie, and Mary in separate canoes. Okay, and that is what we want here. So, now we've got to figure out a way to count the total number of ways that we can put people in canoes. And I actually think it's very rare for the denominator to be the hard one to work out. But I think this just might be the case. We have 8 people. Now, if I were to do my canoes again... we have... See, here's the challenge, I would guess. We've got 8 choices of people, but it doesn't matter who we pick to go in that first canoe, right? You know, if Jeff is the first guy we pick and he goes in a canoe, well, Jeff had to be in a canoe anyway, so it's not 8 choices for the first person, because eventually all 8 people are going to go in a canoe. It's about the pairs of people. That's what matters here. So, we've got to be a little careful. does not matter who's in the first canoe, but there are 7 choices of people that that person could be paired with. Right? Okay, and then how about the next canoe? Is there actually 6 choices of people available? I'm not entirely convinced that there are. Shouldn't the same sort of reasoning apply? And we have sort of... Then how does that person relate to our Jeff here? I feel like that person doesn't matter, but it matters who they're paired with. Same thing, the next choice doesn't matter, because that person will be in one of the remaining 3 canoes. But it matters who they're paired with, and there's 3 people left to be paired with there. So I think this should be out of 7 times 5 times 3, which is 105. And then if we divide top and bottom by 15, we get 4 out of 7. So it should be 4 out of 7 ways to place these people in the canoes. Now let me just sit and think. So Jeff gets placed, but we knew Jeff would get placed in a canoe. Jeff is just a random name, incidentally. Jeff was not in the question. And somebody gets placed with him, and that matters. That pairing matters. Then we've got 6 people left, but we're doing the same problem again. We're just trying to fill up the 6 canoes. Now, is there a way... Well, I worry that maybe I'm double counting, that I might have the Jeff and Barry canoe and then the, I don't know, Tom and Alan canoe counted, and I pick that, and then I pick that, but what if I picked Tommy first and then Alan, and then Jeff and Barry? Have I counted that twice? I don't think so, because it's not about when Jeff gets added to his canoe, it's all about whether or not Barry is with him. So I think we're good. I don't know, I seem to recall, I didn't mark this one, but I seem to recall that there were a couple ways to do this question. I think the answer was something simple like 4 sevens. But I try not to rely on my experience from the marking room as to how I do these things. I am doing this fresh. But I seem to recall there were other ways to do it. And if you got a different way to do the question, I would love to enhance my knowledge of probability. So if you want to include it in a comment down below, I would love to read through it. But I'm pretty confident that our 4 sevenths answer, it's nice, it's basic, and the counting problems haven't been that hard. But it did take a moment to realize that first person in that canoe doesn't matter, because they were going to go in a canoe eventually. So it's just about the 7 people who are picked to go with that person. Wonder if I could count it another way and still get the same setup. Well, no, I'm mostly just worried about the double counting. I think that's okay. I think I've satisfied that. I'm happy with my counting technique here. But again, you know, if I've got it wrong or if there's a different way to do it, I would absolutely love to read it down below. But let's I think move on to 7b. So what have we got here? Diagonal WY of square WXYZ has slope 2. That's kind of an odd way to phrase that. So I guess implicitly here we've got an axis system, and we might have sort of a square built off of a line. Okay. Determine the slopes of WX and XY. Okay. So let's draw our picture, and this is the one we actually have to write up. So I would probably first say something like translate the square so that W is at the origin. As long as we translate it and we don't rotate it, we're fine when we do this. So we can I think we'll have to worry about a little more than the first quadrant, but we should be okay. So, slope of 2 means I go over 2 and up 1, over 2 and up 1, so it's a little steep. Okay, so y is over here, and we'll say that y is at y 2y. Now, that might get confusing with the x's and y's that I might have in the question, so I don't know, let's say a and 2a, I guess. Okay, so w is down here, and then x somewhere over here. I'll put z somewhere up here in the second quadrant. Okay, so we want this slope, wx and wz. Those are the slopes that we want. Okay, so what can we do? Well, I know this angle here is going to be 45 degrees. Does that necessarily help me? And I can figure out the length of wy will be root 5a, whatever a happens to be. So, do we want to work out coordinates for x and z, or is there some other way that we can see to do this? So I suppose we could talk about, yeah, if I knew, I could figure out the slope of wx, and if I knew the slope of wx, the slope of wz is -1 over the slope of wx, since they are perpendicular, and that's probably going to be useful. So I only really need to work out one thing. So it's a 45 here, and I could figure out this total angle and figure out this angle, but what I really want is sort of the rise over run. I want to be able to say it's the cosine of whatever it is. Well, if that's root 5a, then each of these is root 5a over root 2. And that gives me the hypotenuse of wx. We'll call this u. But how high off the ground is x? How high up is x? That's, okay. Because I used the 45 there. Should I maybe drop another perpendicular? You know what, I'm going to draw my picture a little bit bigger. Because it's starting to get crowded, and now I know the area that I want to focus on. So that's 45. We'll call this root 5 over root 2a. And we also could say something like rescale it so that everything is, how do we want to say it? Rescale it so that the side length is 1, and then we'd just be dealing with root 5 and things like that. Or I guess I'd want the side length to be root 2 over root 5, but it doesn't matter. Okay. So there's a root 5a over root 2. 45 there. And we haven't used the fact, really, that it's... So I got a there. This whole distance up here is a 2a. What I'd like to know is, let's say, x and y, so I can do rise over run. So if I knew the coordinates of x in terms of a, I think we'd be all set. So how can I figure that out? Well, let's drop this perpendicular. We've got this one already going. So, it's a height of y, and so this is then 2a minus y. And we have some distance here, and x is going to be that some distance, maybe we call it little z, is z plus a. Yeah. And so this is a rectangle. Is it necessarily a square? I'm not entirely sure. But it is definitely a rectangle. And I'm not making some sort of grand mistake that this is a specific square, and these would be specific slopes. So it's not some sort of weird trick where the answer turns out to be 0 and it didn't matter anything about the y equals 2x part of everything. So what do we want? What would the slope be here? Well, it would be the tangent of this angle. Right? If I knew that, we'd have the slope of wx is the tangent of that angle, because it would be rise, the opposite, over the adjacent, which is the run. Okay, and that's the tan of 2 over 1, or sorry, that's tan of whatever. I'm going to switch back to black here. This larger angle is the arctan, or tan inverse, of 2 over 1. We go up by 2, we go over by 1, slope of 2. So this is the tan inverse of 2 minus 45 degrees. And unfortunately, I don't remember my tan angle formulas, which I probably should, but I think if we redraw this, we can figure this out. So actually, I don't really even need the coordinates anymore. So diagonal theta 45. Okay, so let's say something like let u be on the x-axis. So xu is perpendicular to the x-axis. Or xu is perpendicular to w, whatever you want to say. X, u, y, w. So let angle YWU be, let's say, phi, and angle XWU equal theta. Phi minus 45 degrees is equal to theta. Slope of WX is tan theta. So I just need to figure out tan theta. Now, slope WY is tan phi, which is 2. They give us that in the question. So the cosine of phi, because I think I'm going to need cosines and sines in just a little bit. Cosine of phi, it would be a root 5 Cosine is adjacent over hypotenuse, so it'd be 1 over root 5. Sine of phi is 2 over root 5. And then sine over cos is equal to our tangent. Okay, fine. Now, tan theta is sine theta over cos theta, which is sine of phi minus 45 over cos of phi minus 45. And using the angle formulas that I do remember, we're going to have it's sine and then a cos and then minus a sine and a cos, and they swap. And down here it's cos and a cos, and then a sine and a sine. Now I have to remember the order of these things. And is it plus down here? Let's see. If phi were 45, then we'd want cos of 0, which is 1. So we'd want to add them up, because then we'd have cos 45, and sine 45, sine 45. And that would be cos squared plus sine squared, which would be 1. And up here, what do we want? If sine were 45, well, that's not going to help. Let's say if sine were 90, then 90 minus 45 would be 45. We'd be looking at sine of 45 is going to be our answer. So we'd want sine of the 90 times the 45, because that would just give me cos 45, and then sine minus sine of the 45 cos of the 90, which would be 0. We wouldn't be subtracting anything off it. Okay, good. Okay, I don't know why I just never remember these sine formulas off the or these trig formulas off the top of my head. I don't use them very often, if I'm honest. We use a couple when I teach calculus, but other than that, we don't use a whole lot of trigonometry in first year university math, so I don't really have cause to always be remembering these. But there we go, and hopefully you gleaned from that not just that I don't remember my formulas, which I should, shame on me, but that you can reason your way out of your formulas even if you can't remember. If you remember the general, what does it look like, you can say, well, if the numbers were nice, how would they fit in? How should they fit in? Okay, anyway, let's get back to it. I know sine phi, I know cos phi, and I know sine thetas and sine 45s and cos 45s. So this is going to be 2 root 5, 1 over root 2, minus 1 over root 2, 1 over root 5. And then we've got the cosines went first. So 1 over root 5, 1 over root 2, plus 2 over root 5, 1 over root 2. And this will get us our final answer. Is this the most, well, not the final answer, but it will get us the one slope. And then we negative reciprocal it for the other one. I'm going to multiply top and bottom by root 2. So this will be 2 over root 5 minus 1 over root 5. I don't know why I wrote root 2. It's been a long day. Actually, I suppose I could just multiply top and bottom by root 10. And we'd have 2 times 1 minus 1 over 1 plus 2. And this will be 1/3. And that makes sense because it's a much shallower but still positive angle. Good. So slope Wx is 1/3. And so the slope of Wz is negative 1 over 1/3. So that's negative 3. And the sum of the slopes is negative 3 plus 1 over 3. So that's going to be negative 9 over 3 plus 1 over 3. Negative 8 over 3. And that's our final answer. And we have written everything nice and neat. There might have been an easier way to do this, especially if you could remember the tan formulas. But I would say it all went well. And that's it for question 7. We just wanted to determine the sum of the slopes, so that's it. And we get ready now for question number 8. We'll take a look at that in the next video. Until then, take care, and thanks for watching.